Alright, in this tutorial we're going to be looking at how to fit a linear trend line to our data, and then we're going to create a histogram based on the offset of these data points to that fitted trend line. So the first step is to load in our fits table, or whatever table that you're using with your data in it. And then we're going to open up a new plotting window, and this is data that I've created and it doesn't have any scientific relevance, but we're going to use it here. Just know that you'll probably be using a table that's much different, and the steps will apply to your case as well. So what we want to do is go to Form, and then click this green cross here, and then click Linear Fit, and that's about all. That'll create the trend line that you need for your data. You can also go down here and change the color a bit as you desire. I'll just choose blue because I can. Change the line thickness. You can change the style as well. I think this one works particularly well for our purposes. And this item's a bit neat as well. It'll sort of smooth the line and it won't look as pixelated if you decide to choose that. I'll just keep it off for now. And then if you scroll down a bit further, you'll see that there's an equation. Y is equal to mx plus b, but in this case it's c for the y-intercept and not b. And it's the coefficient list that for the trend line that you've created. So you can actually use these to recreate the trend line if you wanted to. And then there's also the correlation coefficient, which tells you how strongly your points are correlated. If it ranges from -1 to 1, where -1 is strongly negatively correlated, so it'd have sort of a downward slope like this, and then +1 would be a strong positive correlation. So in this case we have a real strong positive correlation, which makes sense because I created this data to have that sort of form. So I would recommend to write these two numbers down somewhere handy because we'll need them in the next step. I'll also mention that if you're not able to really fit a nice linear trend line to your data, maybe it looks a bit more curvy or logarithmic, you can change the axes to log scale like this, and then go back to your data. And if you scroll down a bit further, you'll see that hopefully your line fits a bit better, firstly, but secondly, the equation will be a bit different. It'll be in terms of log base 10. So be sure to try out this step if you think that your data doesn't have in linear space a nice linear trend line to fit to it. But I'll keep them in linear space for now because that's what fits my data best. And again, be sure to write these down because we'll need them right now. We're going to be creating now the histogram plot for the offsets, but it makes sense to first actually have an offset column in our data. So we'll go ahead and create that real quick and call it offset. So the equation for the offset that we'll be using is the perpendicular distance between each point and the trend line, and it looks like this. It's a bit clunky looking, but I'll walk through it real quick. So we have the absolute value of all of our y points minus the y-intercept plus the slope of our data times our x values, and absolute value of all of that divided by the square root of 1 plus, and remember this function from before, it's TOPCAT notation for some number, in this case our slope, multiplied by 2, where 2 is the exponent. So this is equivalent of saying 2.068 to the second power. And just for completion, I'll type the rest of that as well. And then click OK when you're all set, and you should have your offset column all ready. Again, it's the perpendicular distance between the line and whatever point the row represents. So we'll go ahead and click X for now, and then open up a new histogram window, just to the left of the regular scatter plotting, if you will, icon. Yes, that's the word. And then we click offset here, and that's essentially all. Now we have a histogram that better visualizes, I think, the scatter, I guess, of your points about the trend line that you fit to your data. So another idea, if you want to make this maybe a bit more intuitive to read or a bit nicer to read, that there aren't these white blocks in between the bins is to change the bin size to maybe something like this. You can see there's a bit more of a curvature as well, where most data points tend to be at an offset around one-ish units or so, whatever the axis is of, or the units are of y over x. In this case, I'll just say units because my data are random, and not so much on the outskirts here. Almost looks like a Gaussian distribution in a way, which is sort of neat. So again, as always, we can go ahead and download this or export it as my plot.png, put it in my desktop for easy access, move this over a little bit, open it, and voila. I also, of course, recommend adding a nice title and maybe choosing an x-axis that's a bit more descriptive than this. But for the moment, it works because we're really just demonstrating not necessarily good plotting practices, but how to create these type of plots. So that's about that. Let me know if you have any questions.